Okay, let's tackle a truth table problem that's a little more, I hesitate to use the word difficult, but more tedious. This one says construct a truth table for the following statement. It's an OR involving a compound statement and on the left. I'm going to take not P and it with not Q. And I'm taking not P ORed with Q, and then I'm taking those two compound statements and ORing them. Now, what they're asking for, as in the simpler examples, is something that looks like this. You're going to have each of your statements, you have P's and Q's, every possible value of true or false, and then you want to find the truth value of this complicated looking expression, which you'll head here. But to get started, it's just as you do with the simpler ones. You list every possibility of true and false for P and Q. We've done this several times now. And then my strategy is to expand this table and leave me some more room to show my preliminary work within the table. It just seems more organized to do it that way. So using my strategy, what I would actually do is take that table and draw it out so that it has a lot more room in the spaces where I need to show some work. And then I do as with the simple problems, but you really have to be careful here because the statement you're trying to find the truth values of is much more complicated than what we've done in the past. So first row, I want both P and Q to be true, so I will just go in and put T's everywhere. So I get not true and not true, or not true or true. I'm just replacing every P with true and every Q with true. You can work across, you can work down. I've been working down. I think I'll continue doing that. Second row, I put true everywhere I see a P, and I put false everywhere I see a Q. Now be careful, because if you're distracted, you're going to make a mistake. So I put a true for every P. And I put a false for every Q. So it'd be not false, or make sure you copy your symbols down correctly. Now I'm putting true in for P, so that'd be not true, and then that or comes down, and then Q is false, so that would be an F. Moving to the third row, everywhere there's a P, I'm going to put an F now, and everywhere there's a Q, I will put a T. So I'll have not false and not true. Or, be very careful here. Don't invert your signs. Be very careful. Not P would be not false, or Q would be true. And finally, the fourth row, F goes everywhere. So I get not false and not false, or not false and, now there's no negation here, so it's just plain old Q, which is false. Now I'll move back up and I'll keep simplifying. I just take it one step at a time. So I need to write what these statements are equivalent to, taking one step at a time. I'll start inside the parentheses and look at this not true. That not true is false there and there and there. So I end up with false and false. And then that's or. And then not true is false. So it's false or true. Moving down to here, I got not true becomes false, not true becomes false, and not false becomes true. So I get false and not false is true, or, and then not true is false, or false just stays the same. Third row, not false is true, and not true is false. So not false is true, and not true is false, or not false is true, or false. Last row, Not false becomes true in all three places it appears, so I get true and true, or false, not false is true, or false. And I just keep moving. So this statement now is equivalent to, working inside the parentheses, I've got an and I've got an or. That brings me back to the truth tables. I hope by now that they're burned into your brain, but if they're not, I will show them again very briefly. These are the basic truth tables we've had so far. Negation, or, and. We're really not working with negation here. We've already done that. In fact, I don't think you even need to refer to this to do negation. It's just so obvious. But the or truth table is only false if they're both false. So the only time a truth table involving or has a false is if the both P and Q are false. Otherwise, everything is true. And with an and, it's only true if they're both true. In other words, the P and the Q are both true, you get true. Otherwise, no matter what the other combinations are, the and is false. So we've got to use those results here. For an and, it's only true if they're both true. So if I'm looking at this and, it's only true if they're both true. Well, neither one of these is true, so that must be false. So that and right there would generate a false. And then I've got the or. And then this is an or. Now an or, as we just discussed, is only false if they're both false. Well, they're not both false, so it's not false. That means it must be true. And then you move down here and do the same thing again. With an and, it's only true if they're both true. Well, they're not both true, so that and must be false. Then you've got the or. This is an or. When you're oring, it's only false if they're both false. But they are both false here, so that would be false. Going here, you've got an and again. Don't mix up your ands and ors. An and is only true if they're both true. Well, they're not both true, so that and would be false. And then you've got your or. This is an or, and an or is only false if they're both false. Well, they're not both false, so it's not false, so it must be true. And back to this last row, you've got an and, true and true. An and is true only if they're both true, and they both are true. And then you have an or, and then you have your oring a true with a false, and with an or, it's only false if they're both false. Well, they're not both false, so that would be true. Now you're down to your last equivalence. This is an or. An or is only false if they're both false. Well, if you look down here, the only time both of them are false is right here. So that's going to be the only false. That means everything else has to be true. Now really I'm done, but I've got all my scratch work inside my table where I really don't want to leave it. So my last step is I will rewrite this and get rid of my scratch work. It was important to put it there. To me, it's more organized, and you're less likely to make a mistake if you put it right there where it belongs. But once you've done it, it's a distraction. So what you want are the final results in here. T, F, T, T. So this is the truth table for the statement that you were given originally. Nothing difficult about it, but you really do have to be slow, deliberate, very, very careful.